So back after what I would still call a successful day at the dyno. Not everything I'd set out for, not everything I'd hoped for, but that's okay. I took a different approach to what most people would probably do when going to a dyno. I took this car to the dyno knowing that there were problems. Problems that were very difficult to troubleshoot on the street, and problems that still remain today that I still have to look at, but now I have some ideas of what they may be. Most people will either take a working car, a completely functional car to the dyno and just get the results they're looking for, or end up with a new mystery. Or they'll take a car that doesn't run at all and hope on the day that everything sort of works. So I did what would be called as a bit of a street get it right test, making sure things like the drive shaft is balanced, making sure the transmission shifts gears, doing all of those basic tests just to make sure that it would be good enough on the day. But ultimately went to the dyno with known problems with the car and full disclosure to the guy tuning the car that the problems did exist. It was his idea as well that we use the dyno as the tool that it is to help to troubleshoot some of the problems that are there and work through them. So the problems that I've got and the problems that it had beforehand were twofold. One, I've still got that electrical issue that I talked about a video or two ago, where the car will just lose all power to the powertrain control module and several other circuits in the car for a split second, and then they'll come back. That was previously causing me massive issues with my brakes because my booster wasn't working. I've since fixed that, so now it's just losing the power, coming back, but it's a problem. I can't race the car like that. I can't do anything. I was hoping it would show up a lot more on the dyno so I could actually pinpoint the problem. As it turned out, it only showed up once. So I'll pop the video in here so you can see exactly where it happens. In addition to that, the other problem that I have is on the street, I was unable to really build any boost with it. And that's incredibly hard to troubleshoot on the street because I've got to be going pretty fast before it actually builds boost anyway. I'm getting into illegal territories for speed. If it does actually build boost, I'm going to be struggling for traction as it is on the street. So using the dyno for what it is, using it for the tool that it's designed to be, was ideally there to help me troubleshoot that problem. And I believe I've got something there. I've got a back pressure monitor on the hot side between the engine and the turbo, and that was showing quite a high number of back pressure, or quite a high amount, which indicates a problem. It's more than 4-to-1 looking at the scaling that I've got, and I've still got to verify those numbers, but it's more than what I should be seeing. So numbers on the day, obviously we're all going to get there eventually, we're going to talk about the numbers. Numbers on the day, 321 kilowatts, which doesn't sound like a lot, but in a car this light and this small, it's heaps. No, I'm not stopping there. I didn't put an 88mm turbo on this car to make 320 kilowatts. So that's where we're at today. It's also important to mention that's 321 kilowatts at the wheels at 3.5 pounds of boost, because that is all I could squeeze out of it on the day. That's with the boost controller pegged at 100%, with pressure on top of the gate, wouldn't go any higher. So it's got to be some kind of back pressure issue. So there's a couple of things I need to try next, and I'll put some details in the next video of how I go about these and hopefully show what fixes it. So I'll do the fixes individually, but first thing I want to try is I want to get a better boost reference. Currently I'm referencing the boost controller and the wastegate off the intake manifold, which is good, and it would work for most situations. It's worked on a previous car for me without any issue at all. But if I've got a significant drop of pressure between where the turbo is and the throttle is, because it's got to go through the intercooler, the pressure that's holding the gate closed is significantly less than the pressure that's actually the pressure that would be required to keep the gate closed is significantly reduced because of the losses in the intercooler. So that's a problem I'll need to try and address, and it's relatively easy. I just tap a thread into the compressor housing of the turbo and boost reference it from there and run a hose instead of from here to here. No big deal at all. That's a quick and easy. I don't think it'll fix my problem because it wouldn't explain the high readings I'm getting on the back pressure sensor. The second thing I want to do is I want to ditch the 3-inch exhaust completely, and I want to run something that's a bit better sized for the application. I've been trying to run 3-inch for a while. I've put a lot of effort into making 3-inch work because I'm trying to keep it quiet, and no, it is not quiet, but I feel if I go a bigger pipe it's going to be louder again. I'm going to have to go that way. The question is how big and how do I do it now? So at a bare minimum I'm going to have to go 3.5-inch dump pipe. I believe I can fit 3.5-inch from the back of the turbo down to the transmission without a problem. I'm also quite confident I can get twin 2.5 from that to the tip of the car. I would rather do twin 3-inch, and I should be able to fit twin 3-inch, but I'm going to have some complications with fuel lines which will need to be moved, which I wanted to do anyway. I've actually got a coil of hardline up there for next time I pull it out, just to make that a bit nicer instead of running the push lock hose the full length of the car. And I also will have a problem getting past the fuel tank because the fuel tank is slightly offset and it's only really got a 3.5-inch gap down one side. So what I may have to do is go 3.5-inch down, merge into twin 3-inch, and then merge back into single 3.5 to the back of the car. Or I just ditch the fuel tank and put a fuel cell in the boot, which I don't really want to do. So that's where I'm at with that. I'm going to run a couple of videos from the day, a couple of dyno pulls, and I'll overlay them with the graphs from my logging software and just talk to what I'm seeing, talk to the results, and talk to what we're actually doing on the dyno to hopefully paint a picture of how the day went, why we got the numbers we got, why we didn't get more, why I didn't push it harder, and just explain to some of those points as it was explained to me on the day, because I'm all about learning. Obviously I can't do this stuff myself. I probably could if I committed to it, but that's not me. I'd rather leave it to the experts. So I'll run some clips and we'll talk to those, and hopefully everybody understands it.
This is EFI Live. This is what I use for tuning. No, it's not the best, but this is what I have. This is what I've used for many years. I'm no expert, but I know my way around the system here. So running down the left here, logging RPM, engine speed, throttle position, targeted air fuel, actual air fuel, manifold pressure, dynamic cylinder air calculated, transmission temperature, exhaust temperature, which is measured between the engine and turbo. Moving to the right hand side, we've got knock retard degrees, vehicle speed, spark advanced, idle air controller steps, because I've got a cable throttle on this, engine coolant temperature, intake air temperature, and these bottom two are my external sensors. So AD3 is the voltage from the sensor for exhaust back pressure, and AD4 is the sensor on the fuel pressure regulator. I don't have the calibration data for this yet, so I'm just making assumptions on what this data is, but you can see it spikes to like 4.17 volts here for back pressure, which is I think pretty high, and you can see the fuel pressure goes up as well, which is expected because it's a manifold referenced regulator. All right, now I'm going to let the run go through, and we'll play it with some sound over the background just so you can see what's happening. So you can see from that run a couple of interesting things. Obviously, built up power gradually. The fueling is off here, which is a mixture of things. One being incorrect injector data. Two, this is earlier in the day before the fueling had all been sort of done better. But that's not a big deal. It's low manifold vacuum areas, which you don't typically hit on the street. I'm not worried. It's a little bit lean, but as soon as you actually start accelerating again or putting the boot into it, it corrects itself right out. And you can see there, that fueling is pretty much spot on under power. It's requesting 11.5. It's getting around 11.4. It's on the safe side. It's not a problem. But you can also see here, manifold pressure, that's sitting at around 3.5, 4 psi. It's not great. It's nowhere near good enough. Back pressure is extremely high. EGTs are high-ish. These were addressed later in the day. So you can see it peaked there at 781 Celsius. That's partially due to the fact that there's not much spark in here. So we've got 13 degrees of spark. Later in the day, we changed that to about 18 degrees of spark, and it picked up a significant amount of power. At this boost level, it's not an issue to have 18 degrees of spark, even on 98 octane fuel, which is what I ran for the day. It's not a problem, but yeah, that just pretty much shows what it is. You can see the EGTs coming back down to normal pretty quickly. Obviously, I've chopped this graph short, but they returned down to about 450 Celsius in a few seconds, so not a big deal. Another thing to point out here, you'll notice that the air fuel goes very rich after this event. Again, it's injector data, but it's other things as well, like the fact that the factory computer can't really control the small pulse widths that are required to push through this small amount of fuel, because this is extremely high vacuum. We've got 15 kPa manifold pressure here. There's a lot of vacuum. It's extremely small pulse. It just can't do it, but it really doesn't matter. You're not in these zones on the street. You use DFCO to turn off this whole area, so it doesn't matter on the street, and it's not going to hurt anything. So I'm not worried about any of that. But yeah, this isn't meant to be a comprehensive guide on how to tune and how to read these graphs, but I thought it might be interesting to some people.
I certainly don't want this to turn into a bashing session on the tuner. He knows what he's doing. There's problems with the car. The data doesn't lie. The data is there. I'm putting it out there for everybody to see. I probably could have squeezed a smidge more power out of it. Could have put a bit more timing into it, maybe hit the 350 kilowatt mark. But it doesn't make sense to do that. And the reason for that is, if I'm making 350 kilowatts at 3.5 psi at 4.5 to 5,500 RPM, that's great. But once my boost problem is fixed, I'm going to fly past 3.5 psi so quickly that any effort in that pressure zone makes no difference at all. It's going to go from 0 psi straight to 10, like that. It's not going to be there. So trying to squeeze that few kilowatts extra out of it and potentially stressing or maybe even hurting the engine to do so doesn't make sense. So where it's at, it's got a safe amount of timing with a safe amount of fuel with close to no boost. I could bet on it all I want. Set up as it is, it'll run beautifully. So I'll probably do that. And depending how I go for the next few weeks, I probably won't change anything. But when I do and the next video comes out, you'll be along for the journey. So I hope everybody enjoys. Definitely like and subscribe. I'm not done with the car yet. It's going racing soon and we're going for more power. So hopefully everybody enjoys it. Thanks very much, guys.